Okay, in this video, this is part 2 of the review sheet for the final exam for College Algebra. Starting with problem number 16, we're going to find the coordinates of the vertex of the parabola defined by the quadratic function f of x is equal to 2x squared minus 12x plus 3. Now, the way we have to do that, we have to use the equation x equal negative b over 2a. And then we need to identify a and b. Your a is always the coefficient of your x squared term. So in this case here, your a is going to be the coefficient of your x squared term, that's 2. The b is the coefficient of your x term, negative 12. So using x equal negative b over 2a, we substitute the b and the a in that equation. So I'm going to bring the negative over and replace the b with negative 12. So I have negative of negative 12 divided by 2 times a, and a in this case, that's going to be 2. Now, negative of negative 12 will be 2 over 2 times 2, which is 4. 12 divided by 4 is going to be 3. So we know the x-coordinate of the vertex is going to be 3. Now I need the y-coordinate of the vertex. And to find that out, since x is equal to 3, I will replace each x in f of x with the 3. So in this case here, f of 3 would be this. 2 times x, which is 3, and that's squared, minus 12 times x, which is 3, plus 3. And then we'll simplify. I'm going to bring up the 2 to show you that we're not square root of 3. That's going to be 9. So it'll be 2 times 9 minus, now go ahead and do 12 times 3, which is 36, and then plus 3. And when I do 2 times 9, that will be 18. So now 18 minus 36 plus 3. 18 minus 36 is negative 18. Negative 18 plus 3 would be negative 15. So the vertex of this parabola that has the function f of x equal to 2x squared minus 12x plus 3 will be 3, negative 15. Okay. So that's all you have to do there is just find the vertex using x equal negative b over 2a. All right, problem number 17 is sketching the graph of the parabola f of x is equal to x squared plus 4x minus 5. And you're going to follow these 4 steps. In part A, you're going to find the y-intercept. Okay, so to find the y-intercept, you always let x equal 0. So in other words, you're going to evaluate f of 0 by taking this equation, this function, replacing each x with 0. So this will be 0 squared minus plus 4 times x, which is 0, minus 5. So 0 squared is 0, plus 4 times 0 is 0, and then minus 5. Now 0 plus 0 is 0. 0 minus 5 is negative 5. So the y-intercept is the ordered pair 0, negative 5. So that's part A. Now part B is finding the X intercepts. Those are the points where the graph crosses the x-axis. So in this case here, you set f of x to be equal to 0. And f of x is at x squared plus 4x minus 5. We set that equal to 0. And then we factor that quadratic part. So in this case here, we need to factor the x squared plus 4x minus 5 into 2 binomials. So x squared breaks up as x and x. The factors of -5 that gives us a positive 4x will have to be 5 and 1. Since the middle term is a plus, the larger of the two factors takes the sign of the middle term. So that 5 has to be plus and the 1 has to be minus. So I have x plus 5 times x minus 1 equal to 0. And then we set each binomial factor equal to 0. So that means x plus 5 equals 0 and x minus 1 equals 0. And then we solve each equation for x. So for the x plus 5 equal to 0, if I subtract 5, you'll get x equal -5. But the x minus 1 is equal to 0. If I add 1, you'll get x is equal to 1. So that means I have two x intercepts, and they will be -5, 0, and 1, 0. So that's part B. Part C, I'll do on this side, is to find the coordinate of the vertex, and we're not going to be completing the square. Here we have to use the formula for the x coordinate of the vertex. That's at x equal -b over 2a that I went over in problem number 16. So here, your a is the coefficient of your x squared term. That's going to be the understood 1. That's the understood 1 for the coefficient of your x squared term. The b is the coefficient of x. That's 4. So in this case here, x equal -b over 2a is what we have to use here. Your b is 4, so I'll bring the negative over, substitute the b with 4, divided by 2 times a, which is 1. Then if I do -4 over 2 times 1, which is 2, -4 divided by 2 would be -2. So no, the y coordinate of that vertex will be -2. So to find, the x coordinate of that vertex is -2. For the y coordinate, I take the original function and substitute each x with -2. So that means I'll have -2, and that's squared, plus 4 times -2 minus 5. -2 squared would be -2 times -2, or positive 4. Plus 4 times the -2 would be -8, and then minus 5. 4 minus 8 is -4. -4 minus 5 would be -9. So the vertex of this parabola would be the ordered pair -2, -9. And then part D would be just doing the graph, using these points and a point symmetric to the y-intercept with respect to the axis of symmetry of the parabola to sketch the graph of that parabola. Okay, so here's what we do here. My y-intercept is the ordered pair of 0, -5. So on this graph, I go to stay at 0, but go down 5, draw the point. My two x-intercepts are -5, 0, and 1, 0. So I go to the left 5 on the x-axis. The other x-intercept would be 1, 0. That's on the x-axis. The vertex is -2, -9. So I need to go to the left 2 and down 9 and draw that point. Now what I'm going to do here is drawing the axis of symmetry. Now that axis of symmetry is going to be that vertical dotted line going through the vertex of -2, -9, which is right here. And actually, the axis of symmetry is going to be the graph of the vertical line, x is equal to -2. So here's the axis of symmetry. Now, let's look at the distance from this y-intercept to the axis of symmetry. This distance is 2 places to the right. So a point on the left side of the axis of symmetry would have to be 2 places to the left. So here's that point right there with the same y coordinates. So these are the points that I need to draw the graph of this parabola. And that's going to look like this. Okay. So that's what the graph of the parabola looks like. Okay. So make sure that you do follow these 4 steps in problem number 17. All right, problem number 18 is using Gaussian elimination and the calculator to solve the system. Here you got 3x minus 4y is equal to 11 and 2x plus 3y is equal to -4. So in this case here, we need to first write this system as an augmented matrix. And what an augmented matrix is this. You have square brackets. The vertical bar represents the equal sign. The first column will be the coefficient of x. Second column is the coefficient of y. Your c is your constant term. Now, in this case here, you want to make sure that your equations are both in standard form, meaning the x and the y are on the left side and the constant term is on the other side. So the first column will be your coefficient of x in this order, 3, 2. Then the coefficient of y in this order, -4, 3. And then the constant terms will be 11, -4. Now, next will be to come up with the output using your graphing calculator. Okay, so let's clear this chunk out. Now I'm going to enter this into the graphing calculator. So in this case here, I need to start by doing second and x to the -1 for the matrix. Now I'm putting in a brand new matrix here, so I'm going to use my right arrow key to edit. And if you want to, you can put this in matrix A, which I will do here. So I'm selecting number 1. Now let's look at the dimensions of this. I got 2 rows and 3 columns. These numbers here represents the number of rows and the number of columns. The first number, the number of rows, the second number, the number of columns. If you look at this, I have 2 rows, 3 columns. So this is a 2 by 3 matrix. Those 2 numbers I'm going to enter at the very top. So that first number, I'm going to change that to a 2, then press enter. And then for the number of columns, press the number 3 and then enter. Now I'm going to enter each element row by row, starting with the first row, which is going to be 3, -4, and 11. So I'm going to type in 3 and then enter, -4, enter, 11, and then enter. It'll take you to the next row. We're going to enter the next row of numbers. In this case, you're going to type in 2, enter, 3, enter, and finally -4, enter. You want to make sure that you press enter after each element, including the one in the last row and the last column. All right, so to get out of this, I'm going to do second and mode to quit. That'll take you back to the home screen. Next, I'm going to do second and x to the -1. Then I'm going to right arrow over to math. I'm going to use my down arrow key to find the menu item that says RREF, as you can see here, which stands for Reduced Row Echelon Form. Make sure you pick RREF. Then press enter. Now I'm going to retrieve that matrix that I saved in A. So I'm going to do second x to the -1 again for the matrix menu. And I saved it in A, so I will select that first one. I can press enter or select number 1, then close the parentheses, then hit enter. So here's the output that you see here. And you must copy that output straight from the calculator, which is in this case 101 and 01, -2. 1, 0, 1, 0, 1, -2. All right, now, as you can see here, these numbers in the final column represent the values of x. So in this case, my x is going to be 1, and the y will be -2. And here you need to write this as an ordered pair. 1, -2. Okay. Now, I did give you a handout showing you the directions step by step on how to set up a matrix in the graphing calculator. Okay, so refer to that if you need to. Problem number 19 is using Cramer's rule to solve the system. In this case here, we got 4x plus 3y is equal to 15, and 2x minus 5y is equal to 1. In this case here, we're going to set up 3 different determinants, one for d, one for d sub x, and the other one for d sub y. So one for d sub x. The third one will be for d sub y. Now for the d, you'll have just the coefficients of x and your y. Both of these are in standard form. So here, your x coefficients are right here, 4 and 2. The coefficients of y, 3, -5. Now for the d sub x, instead of your x coefficients, you'll have your constant terms in place of that, and you'll still have your y coefficients. So now your constant terms will be 15 and 1. And then for the y, 3, -5. And now for d sub y, your x coefficients will be in the first column, but instead of the y coefficients in the second, your constant terms will be in place of that. So your x coefficients are still 4 and 2. The constants are going to still be 15 and 1. And now we're going to find the determinant for d sub x, and d sub y. So for the d, this will be 4 times -5, -20, minus 2 times 3, that's going to be 6. -20 minus 6 will be -26. And now for d sub x, here we're going from the upper left to the lower right. 15 times -5 will be -75, minus the product going from the lower left to the upper right. 1 times 3, which will be 3. So if I do -75 minus 3, that will be -78. And then for d sub y, this will be 4 times 1, which is 4, minus 2 times 15, that's going to be 30. And then 4 minus 30 will be -26. So I have d sub x, and d sub y. Now I'm going to find out what x and y are going to be. X will be d sub x divided by d. Your d sub x is -78, and d is -26. -78 divided by -26 will end up being 3. And now for the y, that will be d sub y divided by d. D sub y is -26, and d is -26. -26 divided by -26 will be 1. So in this case here, x is 3 and y is 1, so the ordered pair that satisfies that system of equations there would be the ordered pair 3, 1. Okay. All right, problem number 20 is evaluating the determinant. Here I got 3, -2, 1, 2, 4, 3, and then -1, 5, 1. Okay, so here's what I'm going to do. I'm going to rewrite this. Now, in the handout that I gave you for section 6-5, finding a determinant of a 3x3 matrix, the first step is to rewrite the first two columns here. So I'm going to rewrite the first column, 3, 2, -1, and the second column, -2, 4, 5. Now, the way we find its determinant would be this. I'm going to take the sum of the products of these diagonals going in this direction from the upper left to lower right. So in this case here, if I do 3 times 4 times 1, 3 times 4 is 12 times 1, which is 12, and then plus the product of this diagonal going in that direction. -2 times 3 will be -6. -6 times -1 will be 6. And then for the 1, 2, and the 5, 1 times 2 will be 2 times 5 would be plus 10. And then next I'm going to subtract each product of each diagonal going in this direction from the lower left to the upper right. So like on this diagonal, -1, 4, and 1, -1 times 4 will be -4, times 1 will be -4. So I have minus -4. And then for this diagonal, 5, 3, and 3, 5 times 3 will be 15. 15 times 3 will be 45. So I'm going to subtract 45. And then minus the product of this diagonal. 1 times 2, which will be 2. 2 times -2 will be -4. Okay. And then next, I'm going to kind of do this. Of course, you can type all this in the calculator, but I'm going to do this. 12 plus 6 plus 10. And I'm going to write minus a -4 is plus 4. Then minus 45. And again, minus a -4 will be plus 4. In this case here, I will have, if I can get this set up right, 12 plus 6 plus 10 plus 4 minus 45 plus 4. I'll end up with -9. So the determinant of that 3x3 matrix will end up being -9. So that's problem number 20. Number 21 is using a change of base property to find log to the base 3 of 17. Now the way we set this problem up is this. We can use either common logarithms or natural logarithms. I'm going to use common logarithms here. So this would be the log of this number, 17, divided by the log of the base, which is 13. And then I will type this in the calculator. Here we press the log key, which is on the left-hand side, and then 17. You want to make sure you close the parentheses, because whatever that is, you're going to divide that by the log of 3, close parentheses. Now we're going to round our final answer to 2 decimal places. So 2.5789 will end up being 2.58, because this 8 makes a 7 to an 8. So it'll be 2.58 rounded. So log to the base 3 of 17 will be 2.58. And what that means here, if I take 3 to the 2.58 power, I will get approximately 17. Okay, problem number 22 is to expand the logarithm and express it in terms of log of m, log of n, and log of p. So in this case here, I have log of p to the 9th. That's a time sign, by the way. The 4th root of n. all divided by m to the fifth. Now, right off the top, I see a numerator and a denominator, so that means I have a quotient. In fact, it's a log of a quotient. So that means I need to apply the quotient rule by writing it as the difference of the individual logarithms. So I'm going to have the log of the numerator, which is p to the ninth, times the fourth root of n, minus the log of m to the fifth. And I also have here for this first term the log of a product. I'm going to expand that using the product rule as the sum of their individual logarithms. So this will be log of p to the ninth plus the log of the fourth root of n minus the log of m to the fifth. Now I'm going to go ahead and rewrite this because I want to write the fourth root of n as a expression in its equivalent exponential form. So let me bring down the log of. The fourth root of n will be n to the 1/4. And that's because the n has the exponent of 1. The index of 4 would be your denominator. And then minus the log of m to the fifth. Now, for each and every term, I'm going to apply the power rule because I have exponents here. That means I'll pull those exponents in front of the logarithm, applying that power rule. So log of p to the ninth, that 9 goes in front of log of p, plus the log of n to the 1/4, that 1/4 will go in front of the log of n, minus log of m to the fifth, that 5 goes in front of the log of m. Okay. So expanded as far as I possibly can, I end up with 9 times the log of p plus 1/4 log of m minus 5 log of m. Okay, number 23 is solving a logarithmic equation and checking the proposed solution. In this case here, I got log to the base a of the quantity x plus 4 plus log to the base a of 6 equaling to log to the base a of 42. I'll go ahead and rewrite this. Log to the base a of 42. You want to make sure that each side of the equation is a single logarithm. The right side is, but the left side is not. That means I need to condense it as a single logarithm. Okay? Notice I have the plus sign in between the two logarithms. I have the sum of their individual logarithms. That means I need to use the product rule. And I'll write this as the log to the base a of. And I'm going to put the 6 in front of the x plus 4. That's equal to the log to the base a of 42. Now here I'm going to apply the one-to-one property because I have log to the base a on both sides. That means I can set this expression to be equal to that constant. So here I'm going to set 6 times the quantity x plus 4 to be equal to 42. We call that the one-to-one property for logarithms. Now we're going to go ahead and distribute that 6 over the x plus 4 to get 6x plus 24. That's equal to 42. And to get 6x by itself, I'm going to subtract 24 on both sides. Excuse me. Here I got 6x is equal to 18. Divide both sides by 6. X then will be equal to 3. Now that's my proposed solution. It does say check your proposed solution. And the way we do the check is to take the original equation and replace the x with 3. So this is my original equation. So let's replace each x with 3. So I got log to the base a of x, which is 3, plus 4, plus log to the base a of 6 is equal to log to the base a of 42. Now, if you add the 3 and the 4 together, you'll get 7. So log to the base a of 7 plus log to the base a of 6 is equal to log to the base a of 42. Now here I got the sum of the individual logarithms. I can condense that using the product rule. I can condense that as a log of the product. So it'll be log to the base a of 7 times 6 equaling to log to the base a of 42. Well, 7 times 6 will be 42, so log to the base a of 42 does equal to log to the base a of 42. You can see the left side and the right side are the same. So that means x is equal to 3 is the solution to that logarithmic equation. Okay, now problem number 24. Here's another logarithmic equation. Log to the base 6 of the quantity x plus 5 minus log to the base 6 of 7 is equal to 2. And again, you're going to check your proposed solutions. Okay. Notice you only have the logarithm on one side of this equation, so you have to use the definition of a logarithm. But here you need to condense the left side as a single logarithm. Notice I have the minus sign in between the two logarithms. That tells me at the difference of the individual logarithms, I need to apply the quotient rule. So I'm going to condense this as log to the base 6 of x plus 5 divided by 7. That's equal to 2. Okay. A minus sign in between the two logarithms means I need to condense it using the quotient rule. Now here I need to use that definition of the logarithm by converting it into its equivalent exponential form. That means this 6 is the base, the 2 would be the exponent for the 6, and that's going to be equal to that expression x plus 5 divided by 7. So log to the base 6 of the quantity x plus 5 divided by 7 equaling to 2 in exponential form would be 6 squared, or 6 to the second, equals x plus 5 divided by 7. Now if I square that, 6 is going to be 36. That's equal to x plus 5 divided by 7. And to get rid of the 7 in the denominator, since it's a division, I need to multiply both sides by 7. So this will be 7 times 36, and that's equal to 7 times the x plus 5 over 7. I'll put this 36 and this in parentheses. Now, if I do 7 times 36, that would give me 252. That's equal to, here these 7s divide out. You're left with x plus 5. So I got 252 is equal to x plus 5. Now we can solve for x by subtracting 5 on both sides. So that means x is equal to 247. That's my proposed solution for this logarithmic equation. But of course, it does say check your proposed solutions as always. That's what I'm going to do here. Using the original equation, I'm going to replace the x with 247. So it'd be log to the base 6 of 247 plus 5 minus log to the base 6 of 7. That's going to equal to 2. Well, 247 plus 5 would be 252. So we got log to the base 6 of 252 minus log to the base 6 of 7 equaling to 2. Now, again, we have the difference of their individual logarithms. I need to condense that as the log of the quotient. So I have log to the base 6 of the 252 goes in the numerator, 7 goes in the denominator. And that's equal to 2. 252 divided by 7 would be 36. The log to the base 6 of 36 is equal to 2. And if you convert that into its equivalent exponential form, this will be 6 to the second equaling to 36. 6 squared does equal to 36. So here I have a true statement. So I can say x is equal to 247 is the solution to that logarithmic equation. Okay. Okay, number 25 is an exponential equation. Here we got 10 raised to the x minus 7 equals 18. And we're going to round our final answer to the nearest hundredth or to 2 decimal places. Now notice that this exponential expression is already by itself, so you don't have to worry about moving terms over to the opposite side. Now, what we need to do is either take the natural log on both sides or take the common logarithm on both sides. Since we already have a base of 10 given, let's go ahead and take the common logarithm on both sides. So I have the log of 10 raised to the x minus 7, and that's equal to the log of 18. You have to take the common logarithm on both sides. Now there's a rule that says this. If you have the log of 10 to whatever your exponent is, that will be automatically that exponent, because log to the base 10 and base 10 are inverses of each other. So log to the base 10 of x minus 7 ends up being x minus 7. Then that's equal to log of 18. Now let's solve this equation for x. We're subtracting 7. We need to add 7 to both sides. So that means I'm going to have x is equal to the log of 18 and then plus 7. Now I need an approximate value to 2 decimal places. So let me show you how we type this in our calculator. All right, first of all, we press the log key and then 18. You're only taking the log of 18, so you need to close your parentheses around the 18. Whatever the log of 18 is, you're going to add 7 to it. And then the 2 decimal places, this will be approximately 8.26. So the approximate value of x would be 8.26. And let me warn you, don't put the 7 with that log of 18. Doing log of 18, let me show you. Don't do this. Log of 18 and then plus 7. That's wrong. Because what it's going to do there is add 18 and 7 together to get 25, and you'll be taking the log of 25, to be honest. So you want to make sure that 18 is in parentheses, like I have up here. Okay, problem number 26 is this. How long will it take for $5,000 to grow to $7,500 if the principal was invested at 7% annual interest rate compounded continuously? And you want to round your answer to the nearest tenth or to 1 decimal place. So in this case here, we have a $5,000 investment. So that means that P is $5,000. We want it to grow to $7,500. That would be the A, your amount. The interest rate is 7%. 7% as a decimal is 0.07. Here you can change that that percent to a decimal by taking that number and dividing it by 100. You'll get 0.07. And it's compounded continuously. So that means we need to use this formula. A is equal to P times E raised to the RT. Okay, and that's because, in this case here, it's compounded continuously. And we're finding out what T is. Now, let's substitute. The A was $7,500. That's equal to the P, which is 5,000, times E to the R, that's 0.07, times T. Now we need to get the exponential part by itself, that E to the 0.07T. So I'm going to divide both sides by 5,000. So now you're going to have the E to the 0.07T by itself. And if I do 7,500 divided by 5,000, I'll get 1.5. So I have 1.5 equaling to E to the 0.07T. Now, since this is an exponential equation, E and Ln are inverses of each other. So that means I need to take the natural log on both sides of this equation. Taking the natural log on both sides of this equation. And of course, there's a rule that says here, if you have Ln of E to whatever your exponent is, that's going to be your exponent, because E and Ln are inverses of each other. So in this case here, Ln of E to the 0.07T will be 0.07T. That will be equal to Ln of 1.5. And then to solve for T, I need to divide both sides by 0.07. So that means T would be Ln of 1.5 divided by 0.07. But we need the approximate value to one decimal place. So in this case, I'm going to type in the Ln key, press the Ln key, and then type in 1.5. I'm sorry. Ln, then 1.5, close your parentheses. Then that's going to be divided by 0.07. Then hit enter. To one decimal place, that would be approximately 5.8. So it would take approximately 5.8 years for a $5,000 investment to go to $7,500 at a 7% interest rate compounded continuously. Okay. All right, number 27 is a system of linear equations in 3 variables. Here we got 5x plus 6y minus 2z is equal to 2, 2x minus y plus z is equal to 2, and then x plus 4y minus 2z is equal to 0. And here I want to solve this system. Now, what I'm going to do here is label this as equation 1, equation 2, and equation 3 in that fashion. And I'm going to work with 2 equations at a time and eliminate a variable. Let's start with equation 1 and equation 2. Start with that. Equation 1 is 5x plus 6y minus 2z is equal to 2. Okay. This might help. 5x plus 6y minus 2z is equal to 2. And then I'm going to work with the second equation, which is, of course, 2x minus y plus z equaling to 2. Now, what I'm going to try to do is eliminate a variable. Let's eliminate the z. And then I'm going to pick another pair of equations and eliminate that z as well. That way I'll have two equations in the same two variables. So I'm going to eliminate the z. I've already got a minus 2z. So if I want this z to z, I need to multiply that bottom equation by 2. Or multiply equation 2 by 2. So when I do that, this is what I'm going to have. I'm going to bring over the 5x plus 6y minus 2z is equal to 2. The second equation, if I do 2 times 2x, that's 4x. And then 2 times a minus 2y will be a minus 2y. And then 2 times z will be plus 2z. And that's going to equal to 2 times 2, which is 4. Now I'm going to go ahead and add these two equations together. 5x plus 4x will be 9x. 6y minus 2y will be a plus 4y. Equals, now that negative 2z and that plus 2z, that's gone. And then 2 plus 4 would be 6. So I got 9x plus 4y is equal to 6. Now let's work with another set of equations. Let's see equation 1 and equation 3. Now equation 1 is still that 5x plus 6y minus 2z is equal to 2. The third equation is that x plus 4y minus 2z is equal to 0. Let's go ahead and eliminate the z again, since I've already eliminated a z from the first and second equations. Notice I have a 2z, minus 2z, and a minus 2z. One has to be negative, the other one has to be positive. So if I want this to be a positive 2z, I need to multiply equation 3 by negative 1. And when I do that, here's what I'm going to have. I'm going to bring over that 5x plus 6y minus 2z to be equal to 2. But that second equation, if I do negative 1 times x, that's going to be negative x. Negative 1 times the plus 4y will be minus 4y. Negative 1 times the minus 2z will be plus 2z. And then negative 1 times 0 is 0. Now I'm going to add the two equations together. 5x minus 1x will be 4x. 6y minus 4y will be plus 2y. And of course, that minus 2z and the plus 2z adds to 0. Then that would be equal to 2 plus 0, which is 2. And by the way, let me go back here and label this as equation 4, and this one equation 5. So in this case here are my two equations in two variables. Equation 4 is 9x plus 4y equal to 6. Equation 5 is 4x plus 2y is equal to 2. And you know what I'm going to do here? I'm going to eliminate a y. Because I can make the 2y a minus 4y. And I'm going to do that by multiplying that equation 5 by negative 2. Sometimes you have to work with the one that's going to be easy for you to eliminate. There's no set rules for that, but you just have to kind of think about it and think about what you have and try to work with that. So if I bring on that 9x plus 4y to be equal to 6, multiply the equation 5 by negative 2, negative 2 times 4x will be negative 8x. Negative 2 times 2y will be minus 4y, equaling to 2 times negative 2 would be negative 4. Now, if I add those two equations together, 9x minus 8x will be 1x, so just x. The 4y's are gone. And then 6 minus 4 would be 2. So this will be x is equal to 2. But guess what? I've already solved for x. So I know what x is. I need to know what y is, and then I need to know what z is. Let's find out what y is by using either equation 4 or equation 5. So using equation 5, which is 4x plus 2y is equal to 2, I'm going to substitute the x with 2. So this will be 4 times x, which is 2, plus 2y. That must be equal to 2. Well, 4 times 2 would be 8. So it'd be 8 plus 2y is equal to 2. Then if I subtract 8 on both sides to get 2y by itself, that means negative 2y would be equal to negative 6. Divide both, not negative. That's still 2y. And then divide both sides by 2. That would mean y is equal to negative 3. Now I know what y is and what x is. I need to find out what z is by using one of these 3 original equations and substitute the x and y to get z. Now I'm going to use equation 2. Again, you could use equation 1 or equation 2, which is what I'm going to use, or equation 3, but I'm using equation 2. And that's, in this case, 2x minus y plus z is equal to 2. Well, x is 2, so it'll be 2 times 2 minus y, which is negative 3, plus z is equal to 2. 2 times 2 will be 4, minus the negative 3 will be plus 3, plus z is equal to 2. 4 plus 3 will be 7, plus z is equal to 2. And if we subtract 7 on both sides, you're going to get z is equal to negative 5. So that means my ordered triple that satisfies this linear equation in 3 variables will be 2, negative 3, negative 5. And of course, you can do the check on this if you like. Okay. All right, now on to number 28. Solve the system by the substitution method. Here we got x plus y is equal to 3, and y is equal to x squared minus 6x plus 9. That's what I'm going to do. I'm going to go and write this side by side. Here we got x plus y is equal to 3. And then the other equation is going to be y is equal to x squared minus 6x plus 9. And you know what I'm going to do here? I'm going to solve this equation for y. Move that x over to where the 3 is by subtracting x on both sides. So that means I'm going to have y is equal to 3 minus x. And then this is where the substitution comes in. I'm going to take that 3 minus x, which is what y is, substitute it for this y in the second equation. So here I'm going to have 3 minus x equaling to x squared minus 6x plus 9. Here I got a quadratic equation. What I'm going to do is move terms over to the opposite side so that I'll have a 0 on one side. Let's move the 3 over by subtracting 3 on both sides. And I'm going to move the minus x over by adding x to both sides. And notice I'm putting the like terms together. So all of this will be 0. That's equal to x squared. Let's see, negative 6x plus 1x will be a minus 5x. 9 minus 3 will be plus 6. So I get x squared minus 5x plus 6 is equal to 0. Now I can factor x squared minus 5x plus 6 into two binomials here. So I got x and x. Then I need factors of 6 that give me minus 5x. Has to be minus 2 and a minus 3. Then we're going to set each binomial factor equal to 0. So this means x minus 2 is equal to 0, and x minus 3 is equal to 0. Well, for x minus 2 is equal to 0, if I add 2, you'll get x is equal to 2. And then for the x minus 3 is equal to 0, if I add 3, that would mean x is equal to 3. So I know what x is equal to 2, and x is equal to 3. But for each one of those, I need to find out what y is, because the system consists of ordered pairs. Well, let's start with x is equal to 2. And I'm going to use this equation, y is equal to 3 minus x, since that equation has already got y by itself. And x is 2, so it'll be y equal 3 minus 2, which makes that 1. So no, one ordered pair would be 2, 1. And now for x is equal to 3, I'm going to use y is equal to 3 minus x again. So I'll substitute the x with 3, so I have y equal 3 minus 3. That will be 0. So my other ordered pair would be 3, 0. So these two represent the ordered pairs that satisfy the system, or this nonlinear system, I should say. Okay. All right, problem number 29 is solving the system by the addition method. Here I got 4x squared minus 3y squared equal negative 11. And then 5x squared plus 2y squared is equal to 38. All right, so let me go ahead and write that down as well. 4x squared minus 3y squared equals negative 11. And then 5x squared plus 2y squared is equal to 38. All right, I need to multiply both equations by some numbers so that way I can eliminate either the x or the y. Let's try to eliminate the y since I got one negative and the other one is positive. Now, let's find the LCD of 3 and 2. That has to be 6. That's the smallest number that's divisible by 3 and by 2. If I want that minus 3y squared to be minus 6y squared, I need to multiply that top equation by 2. And for the second equation, if I want that 2y squared to be 6y squared, I need to multiply that bottom equation by 3. Now, when I do that, here's what happens. The top equation will be 2 times 4x squared. That's going to be 8x squared minus 3y squared times 2 will be 6y squared equals negative 11 times 2, negative 22. Then for the second equation, if I multiply 3 times 5x squared, that's 15x squared plus 2y squared times 3 will be 6y squared, equaling to 38 times 3. That would be 114. Now we can add these two equations together. You're going to see the minus 6y squared and the plus 6y squared adds to 0. 8x squared plus 15x squared will be 23x squared. That's equal to, let's see, negative 22 plus 114. That's going to be 92. So I got 23x squared is equal to 92. And then to solve for x, we're going to divide both sides by 23. That means x squared is equal to a positive 4. Now to solve for x, we're squaring it. So the opposite of squaring something would be to take the square root. And do not forget about that plus or minus symbol. Anytime you take the square root of something in an equation, you need to include that plus or minus symbol. So this will be x is equal to plus or minus the square root of 4 is 2. So we got x is equal to 2 and x equal negative 2. Now, to find out what y is, we can use either one of these original equations and substitute the x with 2 and negative 2. I'm going to use the second equation, which is 5x squared plus 2y squared is equal to 38. And of course, my x is going to be equal to 2. And I can write this out as x is equal to positive 2, and then x equal negative 2. Let's do that. So I'm going to replace the x with 2, so it'll be 5 times 2 squared plus 2y squared is equal to 38. Now 2 squared is 2 times 2, which is 4, times this 5 in front, that's going to be 20, plus 2y squared is equal to 38. And then to get 2y squared by itself, I'm going to subtract 20 on both sides. That will give me 2y squared is equal to 18. Now if I divide both sides by 2, that would mean y squared is equal to 9. And then take the square root on both sides and include that plus or minus symbol. That means y is equal to plus or minus 3. So for x is equal to 2, it's going to be positive 3. And then for x equals 2 again, that will be negative 3. Now let's try x equal negative 2. Okay, x equal negative 2. So here I'm going to use the same equation, but I'm going to do 5 times negative 2 squared plus 2y squared equals 38. Now when I square negative 2, that's negative 2 times negative 2, which is 4, times the 5 in front, that's going to be 20. And you're going to see you're going to get the same answer. Okay? So if I subtract 20 on both sides, that means 2y squared is equal to 18. You're still going to divide both sides by 2 to get y squared is equal to 9. Take the square root on both sides and include that plus or minus symbol. That means y is equal to plus or minus 3 still. So for x equal negative 2, it'll be positive 3. And for negative 2, it'll be negative 3. So here you got 4 solutions for this system of nonlinear equations. 2, 3, 2, negative 3, negative 2, 3, and negative 2, negative 3. Okay, and finally, number 30. Here we're going to graph the solution set of the system of inequalities or indicate that the system has no solution. In this case here, we got 3x plus 4y is less than or equal to 12, and the other one is 3x minus 2y is greater than 6. Okay, let's take each inequality one at a time. So here I got the 3x minus 4y is less than or equal to 12. Now I'm going to graph that as if I had 3x minus 4y equal to 12. Now notice that the x and the y variables are on the left side, so I'm going to use X and Y intercepts to graph this. All right, if you recall, to find the X intercept, you always let Y equal 0 and solve for X. So in this case here, this y will be 0. So I have 3x minus 4 times y is 0. That's equal to 12. Now 4 times 0 gives you 0. So that means 3x is equal to 12. And what number times 3 gives you 12? That'll have to be 4. So your x-intercept is the ordered pair for 0. Now for the y-intercept. That is, of course, you're going to let x equal 0 and solve for y. So in this case here, using this equation here, I'm going to substitute the x with 0. So it'll be 3 times 0 minus 4y is equal to 12. Well, 3 times 0 is 0, so negative 4y is equal to 12. That would mean that y has to be equal to negative 3. So the y-intercept will be the ordered pair 0, negative 3. Now I'm going to plot that line on the coordinate plane. Let's see here. I'm going to use green here. The x-intercept is the ordered pair for 0. I'll draw that on the coordinate group on the x-axis. The y-intercept is 0, negative 3. There's that point on the y-axis. And it's going to be a solid line because less than or equal to means I'm going to have a solid line. Okay. So using my straight edge, it's a solid line. And it separates the half plane. Now, I need to use a test point to determine which side that I need to shade, this side or this side. So a good test point would be a point that is not on the line. And I will use 0, 0 because that's the easiest test point, and it's not on the line as well. All right, using this inequality, I'm going to replace the x with 0 and the y with 0. So this will be 3 times 0 minus 4 times 0. That should be less than 12. Well, 3 times 0 is 0, minus 4 times 0, that's 0. 0 minus 0 is 0. 0 is less than or equal to 12. That is a true statement because 0 is less than 12. So that means I'm going to shade the region that contains this test point 0, 0. That would be this region above it. I'm just going to do this. All right. Now for the other equation, 3x minus 2y is greater than 6. I'm going to try to graph this as if it was 3x minus 2y equals 6. And again, I'm going to use x and y intercepts. So, of course, the x-intercept, we let y equal 0 and solve for x. That means I have 3x minus 2 times y is 0. That should equal to 6. Well, equal to 6. 2 times 0 is 0, so 3x does equal to 6. And, of course, x has to be equal to 2. So 2, 0 is my x-intercept. And then for the y-intercept, we let x equal 0 and solve for y. So in this equation, we got 3 times 0 minus 2y equaling to 6. Well, 3 times 0 is 0, so negative 2y is equal to 6. That would mean y has to be equal to negative 3. So the ordered pair 0, negative 3 is my y-intercept. Now I'm going to use red for this one. 2, 0 is my x-intercept, which is going to be right here. And then my y-intercept is 0, negative 3, which is right here. Now, it says greater than. That means when I graph the line, it's going to be a broken line or a dotted line or a dashed line. So here's what that line looks like. And keep in mind, it's a dashed line. Like this. And also, to find out which side I need to shade, either the top or the bottom, or left or right, I need to get a, choose a test point. And again, I'm gonna use 0, 0, since that point is not on the line. So I use 0, 0. Using this inequality, I'm gonna replace the x with 0 and the y with 0. So I'm gonna add 3 times x, which is 0, minus 2 times y, which is 0, greater than 6. Well, 3 times 0 is 0, 2 times 0 is 0, and 0 minus 0 is 0. 0 is greater than 6 is a false statement. And with a false statement like that, I shade the region that does not have that test point of 0, 0. So that means since 0, 0 is up here, I need to shade the opposite side of that. Here it is. All right. Now, I need to find the intersection of those two shadings, or the intersection of the red and the green. And that's going to be this part right here. So the final shading would be the one that's in orange that I'm about to shade in orange right now. So here it is. That shaded area represents the solution set for this system of inequalities here. 3x minus 4y is less than or equal to 12, and 3x minus 2y is greater than 6. Okay, so that does wrap up this video for the review for the final exam. That's part 2. I wish you the very best on this final exam, and do reach out to me if you have any questions about any of the problems that were presented in this video. Okay, take care. Best of luck to you.